Let's solve exercise 1.7. What is the mixed strategy Nash equilibrium for the game in exercise 1.6? Assume that Firm 1 chooses a low price at a probability of alpha. It implies that it chooses a high price with the probability of 1 minus alpha. We calculate Firm 2's expected payoff. If Firm 2 chooses a low price, its expected payoff, pi 2L, equals 2 times alpha plus 1 times 1 minus alpha. If Firm 2 chooses a high price, its expected payoff, pi 2H, equals 0 times alpha plus 6 times 1 minus alpha. Firm 2 should be indifferent between choosing a low price and a high price. So we have the following equation and solve for alpha. It is 5/7. It means Firm 1 sets a low price with a probability of 5/7 and a high price with a probability of 2/7. Why should the two expected payoffs be the same? That is because if it is not the same, say pi L is greater than pi H, then Firm 2 will choose the low price with certainty. Given that Firm 2 chooses the low price, Firm 1 will choose a high price with certainty. Knowing that Firm 1 will choose a high price, Firm 2 will switch to the high price. The players always have an incentive to deviate, and it could not lead to an equilibrium. Only when the firms are indifferent between their two strategies can the game have a Nash equilibrium. The same reasoning applies to the other player, and we can find beta, the probability at which Firm 2 chooses a low price. It is 1/3. Firm 2 sets a low price with a probability of 1/3 and a high price with a probability of 2/3.